Okay, so this is my final project. My name is Dimitri Patarroyo. This is a project about classifying zip ties. We were just trying to measure how the machine was working, how the blade was working. So we have categories here from 1 to 5. So the whole idea of the scenario was to establish the type of cuts that the machine was doing. So the idea is that this customer um, wanted to roll out this perfect cut, right? But the reality, while testing, we noticed that the machine wasn't doing perfect cuts. So we have an image here. We got this number 2, 3, 4, and 5 according to the protrusions and straight and rough cuts. So if you go to number 2, it's gonna be a slight protrusion with straight cut. This one here, for instance, number 5, that's gonna be large protrusion with rough cut. So basically, what they wanted to do here was to establish errors versus no errors. So a smooth cut versus the other type of cuts. We had a population of 480 cuts a day. So basically, we established that every cut was about 10 or 9 seconds, and we established a scenario where this machine was going to be used for 8 hours. uh, then the sample was 100 cuts, which represents 20 or about 21% of the population. So that was the whole simulation. And okay, so the methodology, we made batches of 20 cuts. So at the end of the day, we had 100 cuts. But because the machine sometimes broke down or maybe it was overheating or it got stuck, so we just decided to get batches of 20 zip ties. So at the end of the day, we have 100 cuts, but in order to avoid that issue, we had those batches of 20. So I'll show you how we represented that. So the final question is, should this company produce and sell this cutter or not? Okay, so there was also another thing that the client was interested in knowing about, and that was to determine slight protrusions versus large protrusions and straight cuts versus rough cuts. So that also gave the client an idea of, like how many straight cuts we have versus how many rough cuts we have. And that'll give them the sense of knowing what's the range of not only errors, but also how this machine is working. Is it producing more rough cuts or straight cuts? Okay, so let me just show you the dashboard here. Most of the dashboard is related to the total errors versus no errors. So in this case, I have all of the units, that was 2,200. And then we got total of errors 902, which almost represents 41%. So I have here a ratio that I created just by basically opening a new smooth route ratio, which represents the units versus the errors. So here in the first day, I got this 41%. Let's say at the end of the experiment, I have this 55. But we can notice that it's moving around this mean, which is 41. So basically, 41% is the mean. We can see that it's pretty much stable. There's no outliers here. Probably this one and this one. But I would say it's pretty stable in this case. If we analyze here, these box plots, So I'm sorry, this is not an histogram, this is a box plot. We're gonna see that the mean here, in this case, for instance, is 42. In this case, is 51. These are represented by weeks. So we have 4 weeks here. This is only taking like 2 days, but I just wanted to put it down here because I wanted to compare with the other weeks. So this is first week of the experiment, second week, third week, and fourth week. We can see here there's only outliers in the first week. And we'll see that at the end of the experiment, we have this strange behavior. The mean is way up in 51. And the whiskers, you can notice that there's not a lot of variation here. There's a lot of variation here. So let's say it's pretty much stable in terms of the mean, but not in terms of the dispersion week by week. All right, so let's go over here on the frequency errors. I can see that I have the batches here from 0 to 20. So that's the methodology I discussed about before. So we didn't have the 100 cuts right away for a day, but we have batches of 20. But at the end of the day, you'll see that there is an average here of 8. So out of 20 errors, you'll see that 8.46 is the average per day per batch. We can see that also here in the graph. So you can notice that only in this part, kind of between May 4th and May 14th. So here we have the sum total errors versus sum total no errors. So this part versus this part. Again, this represents something similar as here. Like if we start the experiment the first day, we'll see that 47% of the cuts were errors. So from this perspective, I mean, you can see that the machine is not working very well because almost half of the production is failing. Half of the cuts have errors. Okay, so this is just to represent that. This is better to visualize here. And then we got this other part where the client was interested on having the rough versus the straight cuts. So we can see that it's pretty, I mean, it's pretty similar. You'll see that the orange versus the blue ones. So the orange ones are the straight cuts, which are, let's say, the good ones. And the blue ones are the rough cuts, which is basically the client didn't want to have a lot of rock cuts here, but they are having those anyways. So that was basically one of the good sides of this experiment because we're showing the client that the blade, the product is not good. We're probably having 45 to 50% sometimes in these straight cuts versus rough cuts. Okay, so we can see this one here. And at the end of the experiment, we see that is, I mean, there's not much, a lot of variance between these two variables. Okay, and right here, we got the summary and we got all the rough cuts, 463, and all of the straight cuts, 439. So it's pretty much the same. So this experiment, basically, a conclusion is that we can let them know that this is not a good product. That they'll definitely be having a lot of issues with the customers because they're not cutting the way it's supposed to be. And even if the client happens to allow this number two, which is a slight protrusion with straight cut, which is kind of manageable. It's not that bad. Even if they allow to have that, still not that good because they're gonna have a lot of number three, four, and five. Um, so that was basically the conclusion that is represented in this dashboard. And for this experiment, that was something that was done like back in 2020, and it was a real experiment with real data. And this kind of stopped because of COVID, so I just wanted to kind of take that data that I already had and try to analyze this and put it here on the dashboards and try to get a visual summary of this. So it's a better way to let the customer know what is going on with every specific category for these cuts. So we have some images here. Those are real images. You gotta see here number five. This is one batch almost. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these 11 cuts, from these 11 cuts, we already have five large protrusions with rough cuts, which is not a good batch. This one, for number four, three, and two. So just in this image, we don't even have one number one. Um, so let's go back to the dashboard real quick. And we can see that represented here day by day. And if you want to see the ratio, I'm gonna go to this one here. You just pick the day and go to the, in this case, it'll be 27%, for instance. And in this other one, which is a peak, it'll be 57%. All right, so that's everything from my side. And this is the end.